Hey guys, Mr. Riz here to help you out with section 3.1 of chapter 3. So chapter 3 is all about quadratic functions. So we're no longer doing linear functions anymore. We're looking at quadratic functions, so things that are curves, and we'll talk about parabolas and things like that. And today we're going to be looking specifically at the graphs of functions. So got a little warm up here. We got these two equations here. We got f of x is this one here, negative 6x plus 2. And g of x is this one here of x squared minus 2x plus 5. Find the value of each one of these. Okay, let's check our work here. If you haven't paused the video, let's do this now. Okay, so first problem here, f of 3. So what we're going to do is we're going to take 3 and plug it into the f equation. So we would get negative 6 times 3 plus 2, and that's negative 18 plus 2. That's negative 16. All right, next problem, g of negative 4. So we're going to take the g equation. We're going to place all the x's with negative 4. Now, it's really important that you put it in parentheses because when you square negative 4 times negative 4 is a positive 16. If you just type negative 4 squared in a calculator, it's going to square the 4 and then make it negative. So we get a positive 16. Negative 2 times the negative 4 is a positive 8 plus 5. And let's see, 16 plus 8 is 24. Plus 5 would be a 29. All right, next, what if f of n minus 2? Well, what's n? I don't know. No, we can still figure this out. Remember, we're just going to replace the x with the n minus 2. So we get negative 6 times n minus 2 plus 2. We can distribute that, and we get negative 6n plus 12 plus 2. And then we can combine like terms. There's no other n's, so we just have negative 6n. But we can combine the 12 and 2 together, make it 14. All right, next, what is g of negative 1 plus 2? Well, what we need to do here is to figure out what g of negative 1 is. So we're going to replace the x's with the negative 1. So negative 1 squared minus 2 times negative 1 plus 5. So this is g of negative 1. And then we're going to add a plus 2 at the end. All right, so we get a, let's see, negative 1 squared is a 1. Negative 2 times negative 1 is a 2. We got 5 and 2. If we add those all together, 1 plus 2 is 3. 3 plus 5 is 8. 8 plus 2 is 10. All right, and last question here. What's f of negative 3 plus g of 2? So that means we're going to plug a negative 3 into the the f equation. So negative 6 times negative 3 plus 2. And then we're going to plug a 2 in for the g equation. 2 squared minus 2 times 2 plus 5. Ooh, it's big. Let's multiply negative 6 times 3 is 18 plus 2. All right, then we got 2 squared is 4. Negative 2 times 2 is negative 4. And then we got plus 5. Okay, let's do the math here. 18 plus 2 is 20. 20 plus 4 is 24. 24 minus 4 is 20. 20 plus 5 is 25. All right, there's our warm-up. Okay, yay, we got those right. Okay, so there's the state standards. What you guys are focused on, you're going to be able to graph quadratic functions by the end of this, and then, yeah, kind of interpret the values and what those functions mean. Okay, so a quadratic function is an equation that has the form of y equals ax squared plus bx plus c. The thing is, a cannot equal 0. It can equal any other number, but a does not equal 0. And a quadratic function has a graph that is called a parabola. You might have seen them before. There are the U-shaped graphs. Okay. So the key concept here of this parabola is that C is going to be the y-intercept where it crosses the y-axis. Okay. The one thing that we are going to have to look for is the axis of symmetry. And this axis of symmetry is going to be where we can reflect the graph. That key point there is the vertex. The vertex is located on the axis of symmetry, and that's either going to be your high or low, your min or your maximum. Now, the one thing that's nice is that everything is reflected over the axis of symmetry. So if we know the y-intercept is at C, we can find a point at the same value that's equal distant from the axis of symmetry. So if the vertex is at 2, meaning this point here is 2 spots away, if we go 2 spots away the other way, we'd have the same value. So if we kind of know that idea, it's going to help eliminate some of the math we need to do. All right, so we'll worry about how we get the axis of symmetry in section 3.5, but right now it's just negative b over 2a. Okay, so what we were just talking about before, that vertex there helps determine the minimums or maximums. If a is a positive number, so if a is a 1, a 2, a 7, something like that, where it's a positive number, our parabolas are going to make a U shape, or a happy. It's positive, it's happy. If a is negative, like a -2, -4, -1, a is going to be, or the vertex is going to be a maximum. So we'll make a sad face there. So we can determine before we even graph what the equation is going to look like based off of the value of a, whether it's positive or negative. Okay, so if we look at this here, we're going to graph this and state the domain and the range. Okay, so if we look here, we got f of x equals x squared plus 2x minus 3. All right, so if we look at this here, a is a positive 1. Okay, b is 2 and c is -3. So the y-intercept is at -3. All right, a is a positive 1, so it would be a happy face. So we know we are going to have a minimum. Now we can find out where that minimum is by using the axis of symmetry. So we can take the equation here, negative b over 2a. We can plug in our a, which was 1, and our b, which is 2. And we get a -2 over 2, which is just -1. So the axis of symmetry is at -1. Now, if we want to find the vertex or the actual value, we'd have to plug that -1 back in. But we know we're going to have a minimum at -1 something. So then what we're going to do is we're going to make a table. So we're going to pick a table, and we're going to have to get at least 5 points because we're not dealing with a straight line, but we're going to have a curve shape. So we need more values. So -1 is going to be in the middle of our table. We're going to pick a number above it and a number below it, and then another number above that, and another number below that. If we keep all of our points symmetric, it's going to make our work easier. So essentially what we're going to do is we're going to take those values and plug them in to figure out their f of x or their y value. So if I take -1 and plug it back into the equation, -1 squared plus 2 times -1 minus 3, we get 4. So we have a point here at -1, -4. Then, if I'm using symmetric points, I can pick and choose which value I want to use. I could plug in 0, or I can plug in -2. I think 0 is going to be a little bit easier to plug in because 0 squared is 0. 2 times 0 is 0. We just have -3, so that's going to be -3. Now, if I wanted to, we could do the work here with -2 as well and figure out that that equals -3. Or remember, if we got parts that are equal distance, they're going to be the same. Same thing with 1 and -3. They're both 2 spots away from the vertex. So if I plug in 1 squared plus 2 times 1 minus 3, then I'm being 1 plus 2 minus 3, which is 0, means the equal distance apart is also going to be at 0, at the function. All right, so if we're looking at this here, the range is all values that are greater than -4. Because if we look back at our graph, the lowest point is at -4. Everything else goes above. All right, so next, here we go. Let's compare the graph of f of x to a function g of x, where with a y-intercept of -1 and a vertex of 1, 2, which function has a greater maximum? Okay, so if we look at this here, given the information, we can plot. Now, if the y-intercept is at -1, we can put it here, and then we had a vertex at 1, 2. So if this is vertex and we're going up, there's no way that we could be going up to get a minimum. So this is going to be an a less than 0, a -a. Okay, if we reflect that over, we would be there. So we can kind of get at least 2 points there and get an idea of what the curve's going to be. So if we look here, this f of x has a maximum that is at 5. This one has a maximum at 2. Okay, so if we connect the points, the first equation would have had the greater maximum. All right, we can kind of take this and put this into story problems here. So let's look at this one here. We got a ski resort that has extended hours, one holiday weekend per year. Last year, the resort sold, sorry, the mouse isn't up, 100 or 680 ski passes at $100 per holiday weekend pass. This year, the resort is considering a price increase. They estimate for an increase of $5, and they would sell 20 fewer holidays. So we're wondering how much they should charge in order to maximize the profit, and then we'll determine the domain and range. So what we want to do here is kind of look at the variables. We can let X represent the number of $5 price increases that they go through. And so then we can have a profit here, which is 120 plus 5X. And the total could represent the number of passes sold, which would be 680 minus 20X. All right, so if we were going to multiply our price times the demand, we would end up getting a quadratic equation because we could go through and distribute. And then we could simplify the like terms in the middle and move it over so we get negative 100x squared plus. So here, the best probably go through is to figure out, okay, where is the vertex? Where's the maximum? The vertex is going to be on the axis of symmetry, which is negative b over 2a. We're going to plug in our b, which is 1,000, and then over 2a, which is 100. And we should have, yeah, a negative 1,000. It's missing the negative symbol there, over negative 200. Divide those, we get 5. Oh, you're good. All right, so we can figure out that the vertex is at 5. So we can go over, there'd be a peak in the graph. If you guys would put this on Desmos, you'd see that there. But we're going to try to do everything algebraically. So the vertex is at 5 something. Now, where is that 5? We're going to take that number and plug it back in. So if we plug that back in, we can do 120 plus 5 times 5. So it'd be $145. And then we can estimate their profit by plugging that in into our equation here. And we would have about a maximum profit of $84,100. Anything above that, the ticket prices would increase, but the number of people buying those would decrease. So we can go through here. Now, the domain is going to be between 0 and 34 because we can't have negative increases. We can't have more than that, and then we'd have negative people buying it. So that's one thing to look at too. All right, if you guys want to try to do the same thing here, give it your best shot, pause the video, and try to do this next one. All right, so very similar problem here. We can look to see how much they sold at per ticket. So we can go through. So the first part here is we can go through and figure out their ticket, their long seats. Oh my God. Would be the first part of the equation would be 1350 minus 30x, and we would times that by 70 plus 2x. Go through, distribute, find our negative b over 2a. We should get a maximum right at like 22 and a half, I believe. We can go through there, figure out, plug that back in. Yep. All right. Well, actually, we're going to skip average rate of change. Okay. Thank you guys for watching. So the big thing here is make sure you guys are checking in on Desmos. It's going to be easy, but challenge yourself to do this without using Desmos. All right. You guys have a great one. See you later.